Reasoning in algebra and geometry. A theorem is a statement that follows as a result of other true statements. A two-column proof are numbered statements and reasons that show the logical order of an argument. So what we're going to start learning how to do is how to write a two-column proof to prove certain theorems. These are algebraic properties of equality that you learned in Algebra 1. You might not have learned the formal names, but you do need to learn them. The idea of the addition property is that if you start off with an equation where a equals b, then if you add the number c, the same number, to both sides, that equation is still true. The subtraction property says if you start off with an equation a equals b and you subtract the same number c from both sides, that equation is true. The multiplication property of equality states if you start off with an equation a equals b, and if you multiply both sides by the same number c, then the equation is still true. The division property of equality states if you start off with an equation where a equals b, and you have some number c that does not equal 0, and if you divide both sides of the equation by the same number c, then your equation is still true. The reflexive property says that for any number a equals a. So any number is equal to itself. The symmetric says that if you have numbers a and b, and if you can say that a equals b, then b also equals a. The transitive property says for any numbers a, b, and c, if a equals b and b equals c, then we can say that a equals c. In substitution, if a equals b, then a may be replaced by b in any expression, and it'll still be true. So like I said, these are all ideas that you've learned before, and you do them constantly when you're solving equations, but you just might not know the official names of them. You do need to know the names of these properties. So when we're talking about properties of congruence, we just want to relate the reflexive, symmetric, and transitive to our segments and angles that we talk about in geometry. So remember, reflexive says that anything is equal to itself. So segment AB is congruent to segment AB. Angle A is congruent to angle A. The symmetric property says that if segment AB is congruent to segment CD, then segment CD is also congruent to segment AB. So we're just saying it in a different order. If angle A is congruent to angle B, then angle B is congruent to angle A. Transitive property is the one where we bring in three parts. So if segment AB is congruent to segment CD, and that segment CD is also congruent to segment EF, then segment AB and segment EF are congruent to each other. Likewise, when we talk about angles, if angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. I want you to go ahead and pause, and I want you to try to match the statements 1 through 7 on the left with the correct property of equality. So see the first part and see how it may have changed in the second portion from the if to the then, and then see which property that describes. So the first one, it says if JK equals PQ and PQ equals ST, then JK equals ST. That's an example of the transitive property. Second one, if the measure of angle S equals 30, then 5 plus the measure of angle S equals 35. So all we did from the first part to the second was we added 5 degrees to both sides. When you add the same thing to both sides and leave the equation true, that's the addition property. In this one, if the length of AB plus the length of CD equals the length of EF plus the length of CD, then the length of AB equals the length of EF. Now, we're going from one long equation to a shorter one, and if you notice, this plus CD from both sides is gone here. So what we did was we subtracted the length of CD from both sides to have this true equation. So that uses the subtraction property of equality. For says the length of AB equals the length of AB. Anything equal to itself, that's the reflexive property. Number 5, if x equals 4 and y equals x plus 5, then y equals 9. What we did was we took x equals 4 and substituted it for x so that 4 plus 5 equals 9. That's using the substitution property. And number 6, if the measure of k, angle k equals 45 degrees, then 3 times the measure of angle k should equal 135. So we multiplied both sides of the equation by 3, that's using the multiplication property. And lastly, if the measure of angle P equals the measure of angle Q, then the measure of angle Q equals the measure of angle P. So we're saying the same thing, just in a different order. It's backwards, so that's the symmetric property. Hopefully you identified all of these correctly. Next, we're just going to talk about 3 theorems. The first is the right angle congruence theorem. That says that all right angles are congruent. And we should know this because all right angles are 90 degrees. The congruent supplements theorem. It says if 2 angles are supplementary to the same angle, then they are congruent. So if these 2 angles are supplementary because they add up to 180, and then these 2 angles are supplementary because they add up to 180, these are going to be the same because there's only one number you could add to 120 to equal 180. The congruent complements theorem is the same idea, just dealing with complementary angles. If these 2 are complementary and add up to 90, and these 2 are complementary and add up to 90, then that means these 2 angles have to be the same because there's only one number you could add to 10 degrees to get 90 degrees. Now we want to do a little bit of reasoning in Algebra 1 and just get the idea of how we're going to work out geometry proofs. So in this first step, this is the equation that we're given. Then, if we want to solve for x, the very first thing you would do is distribute this. So we would have 12x minus 3 minus 8x equals 17. And that's the distributive property. So the distributive property lets us take this equation and then turn it into this and know that it's still the same. Now, your next step would be to take 12x and combine it with negative 8x to give us 4x. That step in combining like terms is actually simplifying. Then, the next step you would do is add 3 to both sides. So if you add 3 to both sides, we're adding the same number on both sides of the equation. That's the addition property of equality. And then lastly, to isolate x, you would divide both sides by 4 to get x equals 5, and that's using the division property. And that's how we got to our answer. So you should have done work like this in Algebra 1 where you're solving an equation and you're justifying each step. We need to get used to this process. Now, let's work out an example in geometry because it's going to be similar to this, but it'll be a little different in how things work over here on the left side. So, we want to talk about how to find the value of x in this diagram. Now, in your thinking, you should know that these 2 angles are adjacent. Their sides that are not common make a straight line, which means they're a linear pair. These 2 are supplementary because that's what linear pairs are. So you can add these 2, set it equal to 180, and solve for x. So we're going to talk about how to exactly write that up in a 2-column proof. So we start off with the given information that angle AOM and angle COM are a linear pair because that's what the diagram shows us. These 2 angles are a linear pair. That's given. Next, we can say that Angle AOM and angle COM are supplementary because that's the definition of linear pair. It's two adjacent angles that are supplementary. Now, if angle AOM and angle COM are supplementary, that means the measure of angle AOM plus the measure of angle COM will equal 180. And that's exactly what what it means to be supplementary. Then we can say that since the measure of angle AOM is 2x plus 30 and the measure of angle COM is x, we can substitute those expressions in for those angle measurements. Then our next step in solving would be to combine the like terms, 2x plus x, which we said is a simplifying step. Next, we want to subtract 30 from both sides, which is the subtraction property of equality. Then lastly, divide both sides by 3, which is using the division property of equality. So this is what justifying each step in a two-column proof looks like in geometry. Now this might be taking you for a loop because it seems different than what we're used to, but we are going to be working on two-column proofs all year long. And so in class we'll work a little bit more on how this is going to look on your quizzes, your tests, and also the SOL. But I want you to go back, look over all of the properties and terms and theorems that we talked about, and make sure you know the names of them and you're able to identify them, because they're going to be very, very useful. So as we talked about, your vocabulary in geometry is essential. So any vocabulary that we have learned so far, make sure that you go back and learn it. That's it. I'll see you in class.